Okay, now I'm gonna explain how we can implement this algorithm, this iterative algorithm in Python. I'm using PyTorch here. The reason is that in PyTorch you can use the GPU and you can speed up the computations. Why GPUs are better and faster for matrix multiplication. But we define a class, let's call it SVD, and then we initialize it. So the device is whether you want to use the GPU or CPU, and then you have to define two matrices, the P and Q. P and Q are the same as U and V here, U and V here, and you have to specify the number of users, the kind of thing called the embedding size, or the number of the dimensionality that you choose, right? And also the number of items. So basically we use the embedding function. Why embedding function? Because if you remember in here I said that we are going to iterate over all the users and items that we already have a value for them, so we do not go through the null values, right? And this is also seen here, that when we want to basically calculate this, we go through all the available cells, right? So for that, the best option is to have a lookup table. So this is going to initialize a matrix with number of users and number of factors, say k, number of items and number of factors, right? So this become the U and V matrices. Now each time that you are also we are using batch learning basically, and in each iteration we don't want to have all of the, say, 1,000,000 users that we have, right? So each time we have to select, we have to specify the batch size before starting, right? So the batch size, imagine, is 32 or something, so you want to select a subset of the users as well. You can also define it so that you can also use a subset of items as well, but in this case, because you only want to look at the non-null values, only a set of items need to be selected for those set of users. So for that we need the lookup table, meaning that when you define those matrices, so in that forward step that you have a bunch of users and items in that basically iteration, right? You want to pick the corresponding basically cells, corresponding rows and columns of those two matrices, and then it basically you want to get the dot product of them. So now, because these are matrices, this basically gives you the whole thing here gives you the dot product of different basically columns and rows of these two sub matrices that we collect. So here we don't have a vector, it's a sub matrix. PU and QI are, so U is for the user, I is for the item. These are sub matrices of those two P and Q matrix, or U and V matrix, and this line here gives you the dot product of these two sub matrices, and you want to flatten them, flatten the outcome. Next step is to define the hyperparameters. Number of factors, which we use the notation k above. Let's choose it to be 5. Batch sizes, I'm selecting 128. When you have a large memory, you can keep it large value, say 1000 or 500 or something. When you don't have a large memory, maybe you have to keep it a smaller, 32, 8 maybe. The L2 regularization, the lambda we used above, I'm choosing a small value here. Probably I don't want to have a lot of regularization. all of these parameters actually should come from hyperparameter tuning, cross-validation, or whatever method you use. Learning rate for the optimization, you have to specify a number of epochs. So if you have a large, very large data, maybe you want to keep the number of epochs to be small. If you have a basically small data, you might want to keep this to be larger. So in each epoch, we have to partition the data into different batches, basically. So train loader, it should be defined before, right? That basically gives you different batches for all of the data that you have. So here we have users, items, and ratings. So user and item are for the inputs, and R is the target, basically. And train loader basically contains these tuples, batches of these tuples. And here we move them to the GPU for calculation to be done in GPU. So these few lines here is something that you must use whenever you use PyTorch for optimization. Basically resets all of the gradients, because you don't want to use the gradients in later steps. You define the output, and now this guy becomes the estimated value for the target, right? Then you use the loss function. This is gonna be Rij minus PTQ, right, square. After calculating the loss, we have to apply the auto differentiation. Basically it calculates the loss function, derivative of the loss function with respect to the parameters of the model, right? And optimizer step also updates the parameters using the estimated values from the previous step and using the differentiations. Here when we calculate the loss, here now we could actually put the weight decay to be 0, and here we could add the summation of square of all of the parameters here. Or if you want to add L1 regularization, you can do so here, or any type of regularization here it can be done. Usually you cannot do it here because this is a function, right? But now when you apply it on the data, it becomes a number, right? So this is a tensor, PyTorch tensor, and then you can add stuff to it. And so this is how other types of regularization can be done. Basically in the inner loop we go through the batches, and when this is done, we have gone through all of the partitions of the data once. Then in the outer loop, basically we specified the number of times that we want to go through the data, and each time probably want to take the track of the loss function on the validation set or training set or whatever you want to do. You do it here. SVD is one of the best method out there. SVD or its variations have won so many prizes, like Netflix challenges or Kaggle challenges, and it's really helpful to use them in practice. Usually more complicated algorithms like neural networks, those methods don't work in as expected, and one would expect that those methods probably are good in image processing or NLP, maybe for recommender systems. Neural networks are best, but that's not usually the case, and SVD and its variations are actually beat those more complicated methods. So it's really helpful to learn them. I'm going to create more videos explaining other variations later. So stay tuned, and thank you again for listening. parameters.